Please send full screen. That's fine.
Great.
Okay. So, I'm sorry. Hi, for my project, I chose to make NeuroPredict a headache classifier. So, starting it off, why exactly did I choose this topic? As I've said before, I'm a high school student and I'm interested in intersection cognitive science, healthcare, informatics. And based on that, I decided to develop a project that combines the computational thinking with the real world health challenge. And in my case, that was headaches and more specifically migraines. Okay, so why headaches in specific? Why did I choose this topic? Headaches in their various forms are really common and sometimes debilitating disease. Nearly 1 in 20 adults has suffered from a headache every day or nearly every day. And as part of my internship at a pediatrician's office, I've seen firsthand how migraines have stopped children from doing activities that kids in their school could normally do, like playing sports at camp, going to school, going to a proper summer camp, and this affects their development and enjoyment. Each headache disorder presents overlapping symptoms, making a definite diagnosis hard to determine. For example, the pressure and tightness associated with a tension headache could be easily mistaken for the early stages of a migraine. Person with a sinus headache experiences pressure here in the cheeks and in the forehead, and that's also a symptom of migraines. This diagnostic ambiguity poses a serious risk, and that leads to ineffective treatment and prolonged suffering for many worldwide. Patients often self-diagnose based on their assumptions, so they may not get the care that they properly need by going to a medical professional, may get over-the-counter medications that aren't appropriate, and they may go to a doctor's office when a visit isn't actually warranted. So put simply, there is a need for a reliable, objective system that can accurately differentiate between common types of headaches.
Okay.
Okay. So that's where my project, NeuroPredict, comes in. NeuroPredict, as the name suggests, is a headache type predictor and management advisor. It's an intelligent, user-friendly solution that focuses on this exact issue, run by a data-driven classification system and an LLM model. It predicts the type of headache, and I chose migraine, sinus, tension cluster, the 4 most common types, based on user-reported symptoms, educates users using structured, medically relevant information, and offers guidance on home remedies, clinical management, and medical options. For me, in NeuroPredict, I'm not just creating a type of software, but I'm also building a digital mind that can learn from and reason from symptoms in a way that mimics a medical professional's advice. Types of headaches. I wanted to go briefly over this just to get an idea of the medical aspect of what I'm doing. A migraine is a complex neurological disorder marked by moderate to severe, often throbbing pain that lasts days to hours, and is frequently accompanied by nausea, sensitivity to light, sound, and that's known as photophobia and phonophobia, and sometimes visual aura disturbances. A cluster headache is far rarer but extremely intense, producing excruciating stabbing pain around the eye or half of the face, and is typically seen in repeated attacks over days or over weeks. So it may occur over a long course of time, but it doesn't mean the entire day is full of cluster headaches, but rather there may be occasions of cluster headaches throughout the day. Typically, cluster headaches are found with tearing, nasal congestion, eye redness, and so on, because it particularly targets the eye and surrounding regions. Then tension headaches over here are the most prevalent type and what most people complain about. They're normally recognized by a pressure pounding over here near your forehead region and your temples, and it's similar to a migraine without its sensitivity features like photophobia and phonophobia. And finally, sinus headaches occur due to the inflammation of the sinus cavities and are presented as deep, constant pressure in the forehead, cheeks, and bridge of the nose, and often worsen with bending and sudden movement. So that's a quick introduction of the headache symptoms. Going on to how my model was created. This is my website itself, NeuroPredict. I'll go into a demonstration later on, but first on the side, I have an about description in the sidebar and clearly warn that this is for informational purposes and don't use this as an actual diagnosis. Quick description of me as a developer, and if you scroll down more, there's a bit of life hacks on how to stop headaches. Then over here in this section, the user inputs their options, describing their symptoms. So over here, for example, what this best describes how your headache feels, that's going to give you like pressing, pounding, stabbing, throbbing, and experiencing nausea has yes or no. This goes on for 15 more symptoms. Okay, moving on to the coding journey, how I created the model. Okay, The key features of my project are split into two parts. First, the symptom-based ML prediction model, and then a generative AI and LLM-based advice model. First, for the symptom-based ML prediction, the user inputs information about their headache symptoms in the form I just showed you. And then based on that, the model, after doing some data processing, identifies the correct type of headache: sinus, cluster, migraine, tension. Then using that advice, using the type of headache predicted, it goes to an LLM-based model, basically a GPT wrapper using Google Gemini, and that creates tailored management guidance. That includes home remedies, medically approved treatments, and medication recommendations, either prescription or over-the-counter. Okay, going through my coding journey. I started off by finding a data set of Kaggle that had headaches, labeled headache types with a variety of symptoms, including duration of headache, phobias, as you can see on the right over here. And then this data was based on the ICHD-3, or the International Classification of Headache Disorders, 3rd edition. And it was derived from a GitHub dataset that basically had these values. As part of processing, I removed any irrelevant columns in the dataset that I couldn't exactly deal with, like previous attacks, because that deals with frequency and was an incompatible data type, especially because my model itself doesn't deal with them. Additionally, there was duration group, which was specific to each experiment's trial itself rather than describing the patient's symptoms overall. Then after that, I identified any missing values using DropNow, and it looked like there's none of them, so I didn't have to do further processing on this end. And then I encoded categorical variables. The class was one of them. There's also characterization, severity, location. All of them were word-based descriptors rather than a simple yes or no, which could be put into binary. And that I did using label encoder, and then I used the label encoded values and put it into JobLib to later decode and encode the testing data and then the final result. Then using a chi-square test and random forest classifier, I showed the top 15 most relevant features to be used as user inputs, and that's shown on the right over here. Moving on. Okay, handling class imbalance. While I was dealing with the data sets and applying a chi-square analysis, one thing that really stood out to me was the data set imbalance. As you can see over here, migraine headaches have the most at around 1,750 plus, while sinus headaches are around 900. And if you look at the other values, everything else is at least cross the thousands. To fix this issue, I use Mode to generate synthetic examples for the minority classes, and that helps avoid a bias by providing more generalized, equalized data. And then as you can see over here, just for an example, I give the descriptions of each of the classes. So cluster 0 is the cluster headaches, then migraines, and sinus, then tension. Okay. After handling class imbalance, I moved on to model training. Using random forest classifier, it uses 250 decision trees and split it into 80% for training and 20% for testing using train test plan, and ran predictions on this model. Initially, although my precision was pretty high, my recall was particularly low for sinus and tension headaches seen in groups 2 and 3. They were ranging around in 0.6 as both of us saw. So to fix that issue, I tried to improve recall and precision, and that was by first increasing the number of decision trees. I started off with 100 and amped it up to 250. I tried scaling the values, but that seemed to decrease precision and recall rather than increasing it by like a minute value. It turned to 0.83 for tension precision, for example. And then finally, I refined my feature selection, looked at more features that could possibly help. And that ultimately created the values that you see over here on the right. Then I actually ran the model. After creating the model, I first created a sample user input values, 15 values I could input into the model that provided a headache type that I already knew would be migraine, and then tension, sinus, cluster. And after doing that for a bit and determining that the model was actually accurate, I incorporated a user input feature using a simple print statement. And then once I got those values, tested it, and it appeared to be correct. I encoded the values given by the user input, then decoded it using the library from JobLib, and then displayed the correct type of headache. At this point, I transitioned from VS Code to Google Colab, from Google Colab to VS Code. So that would then allow me to incorporate the LLM model. So in the LLM model, we particularly use Google Gemini, the second version, using an API. So I got an API key, then implemented it, created a proper prompt, to give structured medical instructions to make sure it didn't stray away and produce values that I didn't require. And then we inputted the decoded headache type, put it into the LLM model, and made sure it was tailored to the patient's condition. After finishing the entire coding, the backend aspect of it, I moved the model to Streamlit and converted the code to display it, like moving print statements to SD.write, made it more user-friendly by avoiding medical jargon. For example, as we see in some of the features, there was like photophobia, meiosis, conjunctal injection. All of those are more medical terms that an average person couldn't understand. So I tried to make it simpler to understand. Like meiosis, it's instead of saying that term specific, I was like, does your pupil look smaller in one eye? Conjunctive injection. Is your eye more red or bloodshot, for example? Photophobia, sensitivity, light and sound. More features that could better help the user understand. Putting that all together, we finally created NeuroPredict. Now, looking at my workflow to more synthesized version of what I just said, imported my necessary data sets and libraries, which I'll be going over later, processing the data, pre-processing, implementing those three things I talked about, removing values, encoding, and so on. Then training the model using train to split random forest classifier, evaluating the model first by a basic data frame, and then using user input, setting up, and then as I move into lighter shade of colors, this is more front-end aspect. And then over here, I implemented a front-end setup, added the user input form, looked at a real-time prediction, then created LLM generate advice, and that ultimately displays the results all over the page. Then the tech stack, what did I exactly use? When I was starting off in Google Colab, that was my initial web application. I used Pandas, scikit-learn for the ML algorithms, model training, encoding, and evaluation, Smooth and job. So that also aided in deployment. And then in VS Code, I used Google Gemini API to create generative AI. And then once I moved to Streamlit, that was my hosting website where I used HTML and CSS. For the backend code, it was entirely in Python. I didn't use any other language except for the Markdown. Now looking at future applications, where exactly could I implement this model? The primary objective that I see is a preliminary self-assessment tool. While experiencing a headache, the user can identify what type of headache they have and look at the quick description Google Gemini provides to see what treatments they could do at home immediately or go to the pharmacy to get. It helps the user avoid unnecessary visits and it lets them seek medical attention if they think they don't exactly need to go to a doctor. Additionally, if I could expand this project to go more globally, it does provide support in areas with limited healthcare access. So it gives guidance to regions lacking quick access to doctors. And once again, although this isn't a definite diagnosis tool, it definitely does help the patients figure out what type of headache they're doing and figure something out by themselves. And finally, as a final aspect, I see this as an educational tool. You could implement this as an interactive activity, allowing users to identify certain combination of symptoms that causes a headache. I could throw in values for how long the headache day is, if I have certain sensitivities, how my features look like. And based on that, I could predict the type of headache. That allows students to figure out the combinations of symptoms that lead to a certain type of headache. Now, future goals. If I was looking towards the future after this program, what exactly could I do? Well, first of all, mobile app development. I created a Streamlit website. It would be a lot more convenient and accessible if I converted this into an app I could use on a daily basis. Another issue I saw was a larger and more diverse data set. The data set I have currently, based on the GitHub information, is from Ghent University in Belgium. And they haven't specified the diversity, whether it's worldwide, USA focused, Belgium focused. So I would love to incorporate more data sets that are more globally so I could expand this project even more. Additionally, I would like to incorporate age, gender, medical history, create like a profile account so we could see change over time. And as we know, pediatric migraines and adult migraines are vastly different. So it'd be more helpful to look at differences as well. Multilingual support, especially for globalization for non-English speakers, as this project is mainly based in English. Additionally, I would like to incorporate on the medical aspect a pain ranking system in telemedicine. As for the pain ranking system, there is a medically certified guideline from 1 to 10 that tells you how your headache affects your daily life, and based on that tells you how much your pain is actually bringing. And that can help the patient dictate if they need to obtain medical care. And for the medical care aspect, I was thinking of applying telemedicine. That involves professional medical care after the prediction. Either that could be scheduling online visits by coordinating with nearby hospital organizations or providing an address to nearby hospital organizations that could better help the patient. And that sums up our presentation on NeuroPredict. Thank you.
Okay, that was a really nice presentation. You covered every aspect of your project very well. So that actually I do not even I do not have a need to look at the code. I actually mentally am able to understand what you have done correctly. Even the design was very good, and also your explanation was also very good. So good job on that.
Thank you.
And now I think we can move towards your demonstration.
Yes.
Yeah.
Let me stop sharing for a second and pull up the website.
Okay.
On this, let me refresh the page because I have a life hack section that generates over time. So starting off, going to the about section because this life hacks section will generate. I have a quick description of the program itself, one sentence, and then a quick warning saying that this is only for informational purposes, doesn't replace professional medical advice, and always consult a healthcare provider. Quick description about me, the developer. I talked about who I am. I'm interested in the intersection of cognitive science, healthcare, AI, and how this project exactly works. I also let them reach out if they have any questions, especially since Streamlit does engage with GitHub and have further information there. As I was showing before, those are generating life hacks bit. This model is directly generated from generative AI, and it gives a quick life hack section for dealing with headaches. There's getting into a proper water diet, getting enough sleep, using hacks like digital sunset, powering off your phone 60 to 90 minutes before going to bed, mindfulness, especially since stress is such a big trigger for headaches. These 3 life hacks aren't exactly consistent with each one. They do generate 3 new ones every time. Later on, you could see something about nutrition, for example, or maybe the H2 hack will have different specifics. Going into my exact model, title NeuroPredict, and a quick description. Please answer the following symptoms. And if you don't select an option, I've coded it so it will be chosen as the first one. Example, if I just run this program as is with select option for nearly everything, it will provide the basic model results, and that always produces a migraine. And then based on this, I can enter symptoms. Let me put a guide here. I have a guide for what inputs can be done for various symptoms. So let's start with migraine headaches, for example. For migraines, it's the classic for all of them. As long as you input yes, default for all of them, you will get a migraine. And for the sake of simplicity, since select an option does give you the first option, I think I'll just click predict the headache type. And that predicts migraine. This directly, as I said, connects to an LLM model. So it does take a few minutes, like 2 to 3 minutes to process and give you information on how to deal with migraine headaches. So until then, I guess, do you have any further questions you could ask? Because this does take a bit of time. Oh, it popped up.
Yep.
Okay. And it does go over the 3 criteria I mentioned. First, a quick description of migraines just for the user's use. Home remedies, these I find they're most helpful because medicines aren't always available. You need something quick and immediate. So for migraines, for example, reducing sensory input, isolating yourself in a quiet, cold, no light room is definitely the best way to go. Cold compress to deal with the pain, hydration, as we mentioned on the side, avoiding caffeine as a stressor, lack of sleep as a stressor, and relaxation. These are medically recognized remedies that you can apply in your life, and I find that these are more long-term remedies. Like acupuncture won't provide immediate pain, but it may help over time. Chronic, this is divided into common migraines and then more severe ones in case patients do need extra help. Botox, for example, around your forehead has proven to be effective. There is also surgery, as not mentioned here. Surgery of the blood vessels does help, in fact. TMS, STNS, and NVNS are all more extreme versions and typically provide relief in treatment-resistant migraines. And then finally, we move on to recommended medications for migraines, split into over-the-counter and prescription only. Over-the-counter are the more basic ones for migraines. That's going to be NSAIDs, acetaminophen, telephone, and analgesics, which are basically pain reducers. Then just prescription-only ones, which are far more specific, and preventive medications. They're more prescription-based, and doctors would probably provide this to you. You can't get this off the market by yourself. Now, if I, for example, change values, I like to go into sinus tension or cluster headaches. Which one?
Maybe take it for sinus.
Sinus. Okay, sinus headaches, as I've written down, normally last 6 days because, as you know, a cold is pretty long. The headache for the type of sensation for sinus headaches is typically pulsating. As I said, it's a deep inner pressure in your head. So it normally feels like it's throbbing a bit. Nausea does come with sinus headaches, especially for some forms. Sensitivity to sound and light, because sinus headaches are worsened by aggravation. Imagine I go outside when I have a headache and go into a busy atmosphere. You do feel a bit disoriented. Sinus headaches also are a bit severe because of how it impairs your immune system and so on. Then let's see. No, since it's typically concentrated around your forehead, cheeks, your scalp, your temple, neck, scalp tend not to be feel so sore and tender. Aggravation does pose a threat, as shown by sensitivity to light and sensitivity to sound. Sinus headaches, as I've said, they're normally unilateral. In fact, one half of the face, even though like it's normally sinus over here, and so on. So let's put unilateral. Sensory disturbances. Is a bit of sensory disturbances right before because cold impairs your senses a bit. Runny nose, as we know, yes, comes with the cold. Then I'm just gonna throw the following out options because for the sake of time. Let's see. And oh, did I beat the wrong one? That's weird. It did produce a migraine for me before. Let me see. That's odd. When I was running the program before, it looked like the timings were different. So,
It's okay. It's okay. No worries.
okay. Oh, the timing was the only issue. Sorry. Headaches tend to last longer than 6 days. Okay.
Oh,
That was a mistake on my end. Once again, it will generate advice for sinus headaches, and that will take some time.
okay.
Hopefully 1 minute. So until then, oh, okay. Management advice, similar symptoms, home remedies that you normally do for a cold, medications over here, then standard methods like decongestants, nasal sprays, so on and so forth. And that occurs for cluster headaches and tension headaches as well.
Okay, that's great. This was a really good project. Like, if I have to talk about the use case and the problem statement that you choose, that's actually also a very great statement that you have chosen, and also the implementation and the execution. That is just the design is just a cherry on the top, right? Because your PPT design and your actual code design is consistent. And yeah, because I had interacted with you before, I know that because you did many iterations on the design. So I
Yes.
know the hard work that you have put not only for the development but also for the design. So really a good job on this.
Thank you.
And about the presentation, for to be honest, for a second, I had a misconception that I'm sitting in a clinic and I'm talking to a doctor because of the hand gestures and the way you talk. You explained it really well. What symptom is doing what, and like how would it affect the outcome and everything. For a second, I thought I was talking to a doctor.
Thank you so much.
Yeah, that was great. So now I think let's have a chat more. Let's chat.